We initially selected an original project whereby floppy drives would be controlled with a joystick and a button to produce music. After one of our floppy drives was shorted and rendered unusable, we were forced to switch projects. Our new project is a novel input device whereby a computer mouse is controlled by a joystick. We chose this because it's the same interesting sensor setup as the previous idea with the joystick, and because we like the premise of developing something to help people who cannot use mice due to dexterity constraints. For this, users simply rest their hand on the joystick and moves it to track the cursor and applies pressure to click. An overall mechatronic system overview is that it's composed of 4 SpectraSymbol 2.2 flex sensors attached to a flexible wire mounted to a wooden box mounted to a base. Inside of the big box is the Arduino and the breadboards. Inside of the small one, an FSR 400 series force sensor. There's a threshold for the clicking action as the weight of the user's hand may accidentally trigger presses. This is implemented in the code. Each sensor is arranged in a voltage divider setup with resistors of appropriate resistance that are adapted to our software to meet our coded requirements for voltage ranges. The button pictured on the breadboard is a kill switch in case the user is battling errors and their mouse is going all over the place on the screen, which you can't click out of if your mouse is going haywire. Does it work? Well, sort of. We ran into an issue with one of our flex sensors breaking and not producing a signal. This one acts in the positive Y direction. We know this because we swapped out the sensor position on the breadboard, swapped pin positions, changed breadboards, and changed the input pin, all with no success. Another error possibly caused by the first was that the negative Y sensor gave both positive and negative readings. This means that it did move the mouse both up and down with downward deflection, whereas it should only move down. We also attribute this to a broken sensor as we tried switching it out with positive results, just like in the first error. The sensors may have been broken with repeated use after mounting them to the base and taping/connecting everything together, and with repeated testing, as the entire apparatus did deflect and move around since that's its purpose. We do not have access to new sensors, so we are unfortunately unable to resolve this problem, but the overall system does most of what it was intended to, as shown by Nick using a calculator to do some quick maths with it.